Hello, today we're going to be looking at Venn diagrams. Now a Venn diagram looks like this below. I think you've probably seen a Venn diagram before. Now if we have two events, A, the first coin toss is ahead, B, the second coin toss is ahead, we want to see what each of these things represents. This space right here represents that you got an A on the first toss, second toss, so we'll say that this is heads, heads. You got heads first and then heads. Here, this is inside of A, so that means you got a heads first, but you're outside of B, so you didn't get a heads the second time. So this represents heads, tails. Over here, you're outside of A, so that means you got a tails first, but then you did get a heads on the second one. And out in this white space, that's tails, tails. You didn't get either of these conditions. Now we put a rectangle on the outside to represent the whole sample space, so everything is within here. Now in this particular instance, the probability of getting each of these is 1/2, so 1/2 times 1/2 is 0.25 or 1/4. The probability of getting this first is 0.25. The probability of getting tails heads would be 0.25. The probability of getting tails tails is 0.25. Notice in the end, if you add up all the probabilities in the sample space, it should equal 1. Now here's some new terms that aren't just terms of Venn diagrams, but we're going to use some Venn diagrams to describe it. There's union, which is what we were informally using the word or for before, and they write it A, U, B, and that represents either it's in this one or it's in this one. This center point is not counted twice, it's just counted once. The intersection is that it's in both categories, so A and B, and this is an upside down U. Some people say it's like you're spelling and, but there's a B instead of a D, I guess. Um, and then there's complement, which is the outside, and we've talked about a complement. That's come up a couple times where it's saying not set A. And now this term, mutually exclusive or disjoint, this means two sets that have nothing in common. The probability that I roll a 2 and I roll a number greater than 5, there's no way I can do both of those with one roll. So we call those mutually exclusive or disjoint. Now here's an example problem. Deb and Matt are looking for a promotion at a law firm. Deb thinks her chance of getting the promotion is 0.7 and Matt's chance is 0.5 of getting that same promotion. She estimates that the probability that they both get the promotion is 0.3. What is the probability that neither of them get the promotion? I'm not as concerned about that question as I am just making sure everyone knows how to draw a Venn diagram. So I draw this to be a whole sample space, and I have circle A and circle B. Now the probability that you start in the middle, the probability they both get it is 0.3. So we'll start there. We'll call this Deb and this Matt. Now, if this Deb's whole circle adds up to 0.7, that means that these two numbers have to add up to 0.7. So we know that that has to be 0.4. We know Matt's whole circle has to add up to 0.5. So that's 0.3 and 0.2. Now to figure out the question, neither of them gets the promotion, that's on the outside. So if we add up these three, then we get up to 0.9. So there has to be a 0.1 on the outside. And that's the probability that neither of them get it. Now there is an additional rule for the union of two sets. It's the probability of A or B, written informally or formally, is when you add A and B together and you subtract out the and. And I'll just show you once over here that this works. So if I choose a different color, so this is, if I said the probability of A or B, so that's the union, is equal to the probability of A plus the probability of B minus the probability of A intersection B. Oh, that's a terrible B. There we go. So what this is saying is this whole section here is the probability of this plus the probability of this minus the thing in the middle. Because when we add these two together, we're counting that middle twice. And so we have to subtract it out. So the probability of A or B is going to be zero point 0.7 plus 0.5 minus the thing in the middle, which is 0.2, or 0.3, sorry, minus 0.3. So the probability is that either Deb or Matt gets the promotion is going to be 1.2 minus 3, so that's 0.9. That's the probability that Deb or Matt get the promotion. All right, hopefully that's enough to do your on your owns.